Hey everyone, and welcome back to the Curio Flow Show. Ready for another deep dive? Today we're tackling something that's absolutely blowing my mind. Quantum computing.
Yeah, it's a pretty wild field.
I've been doing a ton of research for this one, reading articles, studies, all
Yeah.
that good stuff. And honestly, the future of computing is looking seriously cool.
It's definitely moving fast. What's really fascinating to me is that it's not just about building faster computers. It's about totally rethinking what a computer can even do,
Yeah.
you know?
It's like we're not just upgrading, we're entering a whole new dimension. And one thing that really jumped out at me was this kind of rivalry brewing between these quantum computers and our good old-fashioned classical
Oh,
computers.
absolutely. There's definitely some competition there. It's like a constant back and forth. Remember when Google claimed they hit quantum supremacy a while back with that Sycamore processor of theirs?
Oh, yeah, that was huge. Like 2019, right? They said it did a calculation in seconds that would take a supercomputer thousands of years.
Right. But that really kicked off a wave of research on the classical side. Turns out, folks tweaked algorithms and used some powerful hardware like NVIDIA GPUs, and they were able to speed up their calculations big time. Really challenged Google's initial claims.
Huh. So it's not a total knockout for Team Quantum then?
Not at all. It's more like a constant push and pull, which is actually super beneficial. It drives innovation on both sides.
I like that. Competition breeds progress and all that.
Yeah.
But before we get lost in the quantum versus classical debate, I got to ask about the basics. Like, what are these qubits everyone keeps talking about? They're not your average bits, right?
Not even close. Think of a bit in a classical computer, it's like a light switch, either on or off, 0 or 1.
Right, got
Now a qubit, it's more like a dimmer switch.
the dimmer switch. Okay, how does that work in computing?
Well, it can be on, it can be off, or it can be somewhere in between. It can actually be both 0 and 1 at the same time.
Oh, wait a minute. How is that even possible? It's like breaking the rules of reality or something.
That's the beauty of quantum mechanics. It's the state called superposition. And that's just one of the things that makes qubits so powerful. They can explore so many possibilities all at once. And when you add more qubits, this power, it just explodes exponentially.
Okay, my mind is officially blown. So more qubits means more power. But doesn't that also make things like incredibly complex? Trying to program with these dimmer switch qubits sounds like a nightmare.
It definitely adds a layer of complexity, but that's where quantum algorithms come in. They're instructions designed to take advantage of all this weird quantum stuff. They can solve problems that would literally take classical computers forever.
So it's like they speak a different language.
Yeah.
One that classical computers just can't understand.
Exactly. And figuring out how to translate real-world problems into this quantum language, that's one of the big challenges right now. It's like trying to write a symphony using only the sounds of nature. It requires a whole new way of thinking.
Okay, I think I'm starting to get it, but this is seriously heavy stuff. I could already see why people are so excited about quantum computing, though. We're not just talking about faster computers, we're talking about a completely new way of solving problems. But with all this power and complexity, one thing I keep wondering about is error correction. These qubits sound incredibly delicate, almost too sensitive for this world. How do we make sure they're reliable enough to handle these complex calculations?
That's the big question. Quantum error correction is definitely a major hurdle right now. Qubits are so sensitive to, well, everything. Any little disturbance can mess things up.
So it's like trying to build a house of cards in a windstorm.
Pretty much. Researchers are coming up with some pretty amazing techniques to protect qubits from all that noise and interference. One approach is to use multiple physical qubits to make a single logical qubit. That makes it way more stable and resistant to those errors. It's like having a whole team of qubits working together to make sure things run smoothly.
Teamwork makes the dream work, even in the quantum world. So it sounds like even though this error correction thing is a big challenge, researchers are making progress. It gives me hope that all this amazing potential won't go to waste.
Absolutely. There are so many brilliant people working on this, and the breakthroughs are coming faster all the time. There was this recent collaboration between Quantinuum and Microsoft where they were able to significantly reduce error rates using those logical qubits, like 800 times lower.
800 times. That's insane. Could this be the key to unlocking the full potential of quantum computers then?
It's definitely a huge step in the right direction. It shows we're on the path to building quantum computers that can actually handle the complexity of real-world problems.
Yeah.
Of course, there's still a long way to go, but I'm incredibly optimistic.
This is all so fascinating. I feel like we've only scratched the surface of this quantum world, though. From these mind-bending qubits to this whole error correction puzzle, there's so much to unpack. And we're back for more of the deep dive. I'm still reeling from all this quantum talk, but we're just getting started. Last time we talked about qubits and that whole error correction thing. But now I want to know, what can these quantum computers actually do? From what I've been reading, there's a real race going on to build the most powerful ones.
Oh, yeah, definitely. Companies like Google and Quantinuum are pushing the limits. Remember Google's Sycamore processor, the one with 53 qubits? Well, they've got a new version now, a second generation, with 70 qubits.
70 qubits, okay, so more qubits equals more power. I get that part. But what about this Quantinuum? What are they up to?
Quantinuum has this 56-qubit computer they call the H21, and let me tell you, it's making some serious noise. There's this benchmark test called random circuit sampling, and the H21 just blew Google's Sycamore out of the water.
Wait, hold on. Random circuit sampling, that sounds super complicated.
Yeah.
What is that exactly?
Basically, it's a way to test how well a quantum computer can generate random results. You give it a bunch of random instructions and see what kind of output it spits out. It's something that classical computers really struggle with, which makes it a good test for quantum supremacy.
So it's like a quantum power test.
Yeah.
Seeing who's got the strongest quantum muscles.
You got it. And in this test, Quantinuum's H21 came out on top. But it's not just about brute force, you know? Efficiency matters too. The H21 actually uses way less power than Google's Sycamore, even though it's outperforming it.
So like quantum fuel efficiency. That makes sense. We don't want these things to become energy hogs.
Exactly. Sustainability is a big deal, especially as these computers get even more powerful.
This whole Google versus Quantinuum thing is fascinating. But it makes me wonder, will classical computers ever catch up? If they're constantly improving, could they eventually do all the things that quantum computers can do?
That's a really interesting question. It's possible that with enough advancements, classical computers could solve some of the problems that we think only quantum computers can handle right now. But there are some things, like simulating complex molecules, where quantum computers might always have an edge.
So it's not necessarily one replacing the other, more like they both have their strengths, and they'll both play a role in the future of computing.
Right. And don't forget, quantum computing is still in its early stages. Think about the first computers. They were massive and clunky, nothing like the sleek machines we have today.
Yeah, that's a good point. Imagine what those early computer scientists would think if they could see what we have now. Speaking of mind-blowing advancements, I was reading about some really interesting work on those logical qubits we talked about before.
Oh yeah, that's a really exciting area of research. It's all about tackling those pesky errors that can pop up in quantum calculations.
Right, like having a team of qubits checking each other's work. But I gotta admit, I still don't fully grasp how these logical qubits actually work.
It's like this. You have a bunch of qubits that are a bit unreliable, they make mistakes sometimes. So instead of relying on each one individually, you group them together to create this kind of super qubit that's way more stable. It's like a safety net for your quantum computations.
So you're basically building a more reliable system by combining the strengths of multiple qubits. Didn't Quantinuum and Microsoft do some work on this recently?
They did. They were able to create logical qubits with error rates that were like 800 times lower than what you'd normally see with a regular qubit.
800 times lower. That's incredible. Does that mean we're close to having quantum computers that are truly fault-tolerant? Ones that can handle all those complex real-world problems?
It's a big step in that direction. And what's even more exciting is that there are tons of different approaches to error correction being explored right now. It's a super active area of research, and we're bound to see even more breakthroughs in the near future.
It really feels like we're on the edge of something revolutionary here. Like we're watching the birth of a whole new era of computing, one that could change everything from medicine to material science to artificial intelligence.
Exactly. One area where I think quantum computers will have a huge impact is drug discovery and materials design. Imagine being able to simulate molecules at the atomic level. That would allow us to create new drugs and materials with incredible precision.
Wow, that would be a game changer. We could design new treatments for diseases or invent materials with properties we've never even dreamed of. The possibilities are endless.
Absolutely. And another area where quantum computing could be a big deal is cryptography, which is all about secure communication. You see, quantum computers could potentially break some of the encryption algorithms we use today to protect sensitive information.
Hold on, so our current encryption methods might not be safe from these quantum machines. That sounds kind of scary.
It's something that cybersecurity experts are definitely worried about. But the good news is that researchers are already working on new encryption methods that can withstand quantum attacks. It's a race against time, but one that we absolutely need to win.
It sounds like quantum computing is both a threat and an opportunity when it comes to cybersecurity. It's amazing how this one technology could disrupt so many different fields. But with all these incredible advancements, it's easy to feel overwhelmed. It's hard to even wrap my head around all of this sometimes.
It's a complex field, for sure, and it's moving at a breakneck speed. But one thing that I find helps is to focus on the potential applications, to imagine how this technology could solve real-world problems.
I like that. Focusing on the impact makes it feel more concrete, less abstract. And I think that's a good takeaway for our listeners, too. Don't get bogged down in the technical details. Just think about the big picture. The potential of this technology to change lives is what really matters.
You said it. Quantum computing might seem like science fiction, but it's quickly becoming reality, and we all have a role to play in shaping its future. It's important to stay informed, to keep asking questions, and to be part of the conversation.
Couldn't agree more. And on that note, we're going to take a short break. Stay with us because when we come back, we'll be wrapping up this deep dive by exploring the potential impact of quantum computing on society as a whole, including some of the ethical challenges that come with such a powerful technology. All right, we're back for the final stretch of our quantum computing deep dive. It's been a wild ride, but there's one more thing we got to talk about. The big picture. How is all of this going to affect society?
It's a really important question. Quantum computing isn't just some scientific curiosity, you know? This is a technology that could completely transform everything. Industries, economies, even our daily lives.
Right, and that brings up like a whole other layer of stuff to think about, the ethical side of things. With great power comes great responsibility and all that.
Absolutely. Any new technology, especially something this powerful, has the potential to do both good and bad. We need to be really careful, make sure we're developing and using it responsibly.
One thing that comes to mind is jobs. If quantum computers can automate stuff that humans do now, what's going to happen to the workforce? Could this lead to like massive job losses?
Yeah, it's a valid concern. Some experts think that certain types of jobs, especially ones that involve repetitive tasks or data analysis, could be automated by quantum computers. But we also have to remember that historically, new technologies have always created new jobs too. Jobs that we couldn't have even imagined before.
So maybe it's not all doom and gloom. It's more about adapting, right? Making sure people have the skills they need for this quantum future.
Exactly. We need to focus on education and training to prepare people for the jobs that will be in demand. And those jobs might require different skills than the ones we need today. Things like creativity, problem solving, and emotional intelligence. Things that are hard to program into a machine.
That makes sense. So it's not just about building these powerful machines, it's about building a future where humans can still thrive alongside them. I was also thinking about bias. Like if these quantum algorithms are trained on data that's already biased, could they make existing inequalities even worse?
Oh, absolutely. That's a huge concern. The data we use to train these algorithms needs to be diverse and representative. If it's not, we risk creating systems that are unfair, that perpetuate those existing biases.
So it's not enough to just build powerful quantum computers. We have to build fair and ethical ones too.
Right, and that's going to require people from all different fields to work together. Computer scientists, ethicists, social scientists, policymakers. We need to be having these conversations now while the technology is still developing so we can make sure it's used for good.
Yeah, we need to be proactive, not reactive. Shape this technology in a way that benefits everyone. And honestly, when I think about what quantum computing could do, it's pretty inspiring. Imagine using these machines to create new, clean energy sources, develop life-saving drugs, or even uncover the secrets of the universe.
The possibilities are incredible, right? It's like something out of science fiction. But it's important to remember that technology is just a tool. It can be used for good or for bad. It all depends on us, on the choices we make.
Well said. And I think that's a great place to wrap things up. It's been an amazing journey exploring the world of quantum computing. There's still so much we don't know, but one thing's for sure.
Yeah.
This technology is going to change the world in some pretty major ways.
It's been a real pleasure diving into these topics with you. I'm excited to see what the future holds for quantum computing.
Me too. And to all our listeners out there, keep that curiosity alive. Keep learning, keep asking questions, and be a part of the conversation about how we shape this incredible technology. Thanks for joining us on this deep dive into the world of quantum computing.